Okay. Hi everyone. I am Sneha from the Web3 Compass, and this is day 12 of 30 days of building with Solidity. I know, it's a Saturday. Everyone's in the weekend. Why? But come on. If the team is shipping, so can you, right? You just need an hour or maximum two to get this done, and then you can just rest throughout the day. For everyone who has been with us for all these days, you can just skip to the next part where I get into remix and start coding. And for those who has stumbled upon this video randomly, you can go to my day 1 video. That is where I talk about the campaign in detail. Or you can go to web3compass.xyz and search on the website. This is our challenge page and this is day 12. So the contract that we're going to write about is a token contract. It's called MyFirstToken.Sol, and it's a very, very well-known project. Everyone who starts with Web3 development creates their own token one day because it's very fascinating, and then it has use cases that comes in when you're building some real world applications, maybe launching your own games and you want your own token to be used in it, right? So yeah, the example application would be, let's make your own digital currency. You will create a basic token that can be transferred between users, implementing the ERC20 standard. We will talk about all of this in detail and also look at how we can write this token contract using OpenZeppelin in just 5 to 6 lines of code instead of implementing it from scratch. And just like I mentioned, it's like creating your own in-game money, demonstrating how to create and manage tokens. So let's head to Remix. Okay, I've already created the file. Great work. Okay. So as of now, we've built calculators, wallets, piggy banks, and even an ETH wall talking about ownership, inheritance, and all of that. And along the way, we've learned so many concepts, okay? So now, if we want, instead of just holding or moving around ETH, we wanted to create our own token, right? Have our own cryptocurrency. Like, I don't know how many of you are aware of, but there are a lot of meme tokens going on in this space, Dogecoin, Pepe, and all of that. They're everywhere. But okay, launching a token is not that easy. It has a lot of background and compliance and all of that stuff involved. Right now, what we're going to use, I should say what we're going to write is going to be very, very educational basis. We are not teaching how to, launch your own meme token and get money or make money out of it. It should just be limited to your projects that you created and then use it in your project. And, okay. Now, everyone says, or you, in fact, while I talk about my token, right? You would have heard of ERC20 as a standard, and we'll talk about it in detail as we proceed. So back in the early days of Ethereum, everyone was really, really excited about the idea of creating tokens. And so they did, like, lots of them. But there was one big problem. Everyone built them differently. One token had a transfer function that you send. Another one called it move token. Some tokens didn't let you check balances. Others didn't emit any events while transfers were happening and all of that. So now imagine being a wallet or a crypto exchange trying to support all of them. Every time a new token came along, you would have to write custom logic just to get it work, right? Just to get in place. So it was like trying to build a universe remote, but then every TV manufacturer decides to use a very different button, different wire, no power switch at all, and blah, 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 like just random, whatever they felt like, they would just implement it. So the entire Ethereum community came together and said, hey, enough of this. Let's just all agree on one standard and a common way to build tokens. Okay. And that is when ERC20 was proposed. A simple set of rules. This is what a token should look like. These are the functions every token should have. If you follow this, your token will work with wallets, dApps, exchanges right out of the box. Okay. And that is when the birth of ERC20 happened. Now, for everyone thinking, hey, what is this ERC20 at all, right? So ERC stands for Ethereum Request for Comments. It is basically a public proposal that says, hey, Ethereum devs, here is a set of rules and behaviors we think everyone should follow when building a certain kind of smart contract. And yeah, it was the 20th proposal in the ERC series, and it just so happens that to be the one that defined how fungible tokens should behave on Ethereum. Now, again, there are two concepts around fungible and non-fungible, right? So in layman terms, you could just say that fungible tokens can have like smaller denominations, they can be exchanged and are not unique. But when you're talking about non-fungible tokens, which is another, that is what we called as NFTs, and we'll follow some other standard there, and that is where we talk about it. But with NFTs, they cannot have smaller denominations. I mean, they cannot really be broken down and then they are all unique. You cannot have two of the same kind, something or the other would be different. So yeah, just layman terms, right? We'll talk about it more, and there are a lot of resources out there where you can read about fungible tokens and non-fungible tokens, but you should just quickly understand it with a point that if I give you a 100 rupee note and you give me 50 as two different notes, the value still remains the same, right? But you cannot really break a non-fungible token and say, hey, here are parts of it, okay? You cannot do that. And yeah, you can exchange it. Like, you don't like my 50 rupee note and I say, I need the new ones, and you say, okay, fine, just exchange it. I'll take the old ones. The value is the same. But with NFTs, you cannot do that. But anyway, let's focus on ERC20. Okay, so ERC20 lays a consistent interface, a shared language that all tokens should speak. It covers something like naming and display, because all your tokens should have a name, a symbol, and decimals to for the wallets to show them correctly, right? Now, balances in supply. There must be a total supply and a way to check how many token an address owns using balance of address. Transfer, there should definitely be a transfer function that helps or lets people send tokens from their wallet to someone else. Approvals and delegated spendings. For example, your token should definitely have an approve function where users can let someone else, like a smart contract, spend tokens on their behalf after they've gotten approval. It's like me telling Setu that, hey, you know what, here's the entire fund of the company and you can spend 20% of it without my approval if there's a need to buy something for the company. But if it's, more than that, let's just put all the teammates together and decide on it, right? So there's an approval and delegated spending and a transferFrom function to actually carry out these approved transfers. Again, there are event emissions so that whenever tokens move or permissions are granted, your contract should emit transfer and approval events. These help wallets, dApps, and block explorers track what's happening on chain. Okay. Now, why these matters? Because now, once you're following these rules, your token becomes a plug and play. It can show up wallets in MetaMask, be traded on decentralized exchanges, work with lending protocols, DAOs, etc. Right? So, if I have to summarize ERC20, I can say that it's the blueprint that made Ethereum's token economy really possible, and why tokens are interoperable, reusable, and instantly compatible with the ecosystem. Otherwise, hundreds of people would be implementing 100 of different standards and going about it. So yeah, I think it's time that we build a minimal ERC20 token from scratch. Now you can have a lot of functions in it, but we're going to look at some major ones. It won't have functions like minting, burning, or advanced features, and it skips some safety checks that you would normally want in production. So whenever you're writing or you're building a dApp that is going to go into production, which is going to use ERC20 token, please remember that this is not what you can follow. There are more secure standards out there. You can check out OpenZeppelin's standard. We'll add the link to that as well. But yeah, this is perfect for understanding how tokens actually work under the hood. And our token will be called maybe Web3 Compass token or Compass token. And then we'll decide of a symbol as well, right? So yeah. Let's just go about it. So now that I've talked about this in detail, you know that we're going to first think of the variables that we need, the mappings that we're going to look into, now also events, and then move to the function side of it, right? So when you're creating your token, what is it that you would need, right? I think a name, a symbol, the decimal places, so that we can, generalize it, because we know that Ether in general works with smaller conventions to the power of 18. So we keep it like that so that it's easier to just exist. Yeah. And then we're also going to talk about what is the total supply. So let's just get writing. String public name. What? Web3 Compass. Okay. Then we need a symbol. String public symbol. Okay, it says WBT. Fine. I'm missing a semicolon here. Sorry. UNT8 public decimal 18. Now, for everyone thinking, oh, why did we not use 256? Come on, this is a smaller number. This is a fixed number. So we can use smaller slot so that it is more gas optimized. And I mean, when you know that a thing can fix in a small box, why would you bring like a huge carton box, right? And then you say UNT256 total supply, and we will not specify anything right now here. We'll just let it be. Okay. Now that we have name and we have symbol and decimal, okay, it says, hey, I need a mapping for each address with the value, because I have to check how much each of us has balance, right? Or each address has balance if I'm doing some transfer. Makes sense. Okay, great. AI is just working fine. Balance off, maybe. Easier to think, right? Balance off a particular address. And then say, maybe I would want a mapping of, if I am delegating these tokens, right? So suppose I'm delegating it to Setu, that, hey, you can spend 20% of it. And then if there's more, then maybe let's have the entire team together, sit and decide that if this is worth the money. And then Setu has like 2 interns under him. So he says, okay, guys, listen, I have got an allowance of 20% from Sneha. Sneha has got it from someone else higher in the team. And so I am giving you guys a 10% allowance, where you say that if you have to buy a membership or a subscription for ChatGPT or whatsoever, you can just spend it without asking to me, but you have to submit the bills and whatsoever. But if it's more than that, or you're buying a subscription which is more expensive, let me know, right? And the same he does for that, does with me, right? So I will say, okay, I am the first person to allow it. So I'll say address. There should be a mapping between my address to his address and the value that I am allowing anybody. Okay. Yeah. So if Setu is the person allowing me, then it will be his address and then map to my address and how much has he allowed me as an allowance. Okay. Great. So fine. Now what? We know that once we create the token, we are going to do some transfers, right? So we need an event for it. I think it should be understandable now since we've talked about event and emit a lot. Now, wow, AI is really helping, but still, I'm not liking the fact that I'm not writing the code. So I'll say, okay, address, index. Again, indexing helps you search according to a particular value rather than having to go through the entire thing. And then I'm saying, okay, from, and then there will be address indexed to. Okay, great. Now what? Obviously, value. Come on. Very simple. Great. We've got smart at this. And then maybe if someone's asking an approval and I'm using this contract in the front end of my dApp, I would say, if someone's asking approval, there's generally a notification. So I would also want to write approval, right? So again, I'll say, okay, event approval and address index owner. Obviously, the owner has to give, and then there will be spender, whosoever is getting the approval, and then obviously UN256 value. Great, right? Fine. Okay. I think this is done. Now it's time to write the constructor. Constructor would generally set the owner of the contract as message.sender, right? So this time, we have to set something else. We want to set the total supply instead of the owner because again, we are already doing an approve function for it. So I'll say, hey, you know what? Let's just set an initial supply. Okay. And we want to get a total supply for that, right? So I say, okay, total supply should be equals to whatever decimal places that we are setting up to, right? And we will go forward with the 10 to the power 18 of it so that when you are creating 5,000 tokens, it automatically goes as 5,000 into 10 to the power 18. So I say, hey, it should be into 10 to the power and decimals. Okay. Now it's already UN256. Right. This is also UN256. Great. What is wrong? Anything? But if somebody 10 to the power 18, 5,000 suppose. Do we need to make it a 10 to the power 256? No. Let's see. Let's see what happens if we don't. Okay. And then we also want to do something called as the balance of message.sender. Like if I'm creating the token, then it should all be my balance. Like, come on. Then only I'm giving it out, right? So it should do. Okay. And once you do that, it says, hey, you know what? The transfer section should happen, but it's happening from address 0 to the message sender. And that would be the entire initial supply that we are talking about. Okay. But is there any problem in understanding that what have we done till now? Like, we know that this constructor runs once and only once when the constructor is deployed. So what we're saying that, hey, you know what, there should be an initial supply. It's the number you pass when deploying the contract. But then ERC20 tokens use decimals for precision, just like ETH does. And it uses away, right? So if your token uses 18 decimals, which is a standard, and you want to create 100 tokens, you actually need to represent it as 100 into 10 to the power 18. That is why we multiply the initial supply by 10 into decimals. And that scaled number is stored in the total supply. Okay. Now, the entire supply is given to the person who has deployed the contract, which is again the message.sender. That means the deployer starts with holding 100% of the tokens. Okay. Now, from there, they can transfer, sell, or distribute tokens however they want. Okay. And this will emit a transfer event to signal that, hey, the tokens were minted. Now we set the from address as address 0, which is a special way of saying that these tokens did not come from another user. Okay, they were created out of thin air. Okay, wallets, explorers, and front-end tools understand this pattern and display it as a minting event. So that is why we have done this. Oh my God, who wrote this entire thing? I didn't. Come on, remove this. We want to write the code on our own, isn't it? Yes, we do. So, okay, we were here, right? And now even the code was suggesting that it's time that we start getting into functions. Okay, so now that we've written the constructor and implemented everything, we would get into implementing the functions. Okay, now the first function that I can think of is a transfer function. But wait, we discussed two things. First is that if I have deployed the contracts, I am doing the transfer to like multiple accounts. I'm sending it to Setu, I'm sending it to interns, I'm sending it out wheresoever, right? But then what if I'm like super busy making these YouTube videos and I don't have the time to actually do all of these smaller transfers? So I say to, hey, if somebody asks for around 20% of the tokens, make sure that you transfer it without asking from me. And then for the later ones, let's just ask or sit with the team and decide if this is a necessary spend or not. So then Setu will be doing the transfer on my behalf. So there are two different transfer functions that we're talking about. One is where I transfer the tokens directly, and then there's another transfer from which says, okay, Setu can transfer on behalf of Sneha, right? So a little bit of changes around the transfer here. The logic will be a little different. So what we'll do is we'll first write a helper function. Okay, we'll do a logic split so that we don't have to repeat the same things again and again and just make amendments required. Okay, so let's just say that our main function would be called function transfer. So we're saying this helper function should be called underscore transfer. Okay, like, come on, why would we want to write similar kind of codes? We're looking for optimization, right? So we're saying, okay, address from, okay, address to, and then uint 256, again, value. And this has to be an internal function. Okay, why? Because I'm only approving it internally, and it can be only called from within the contract or its derived contracts. Okay, not by any external users. I'm not giving anyone the access to spend it on my behalf, right? Or other contracts. So this is why this is like a deliberate choice that we're making, that, hey, we don't want calling underscore transfer directly and bypassing important checks like allowances, right? So we're saying, okay, now what we will say is few conditions, right? We have to make sure that the recipient's address is not the 0 address, because that would effectively burn the tokens. It would just go to nowhere, right? Because that address does not really exist. So we're saying, hey, you know what? Underscore 2 should not be equals to address 0. Okay. And instead of, like we can say cannot transfer to a 0 address. Great. And then we say, okay, now I will just use balance of, right? We've already created it. And then I'm calling from, because that is the account it will be debited from, right? And we're saying, hey, minus equals to underscore value. Okay. Now, similarly, balance of underscore 2 is plus equals to underscore value. Very simple addition, no logics here. And then we'll just emit transfer from to value. Oh my God, let's not look into this, right? Now we've already created an event here, right? And that is what we are passing here. Okay. Now, we definitely looked into a few checks. We were making sure that the recipient's address is in 0 address. It subtracts amount from sender's balance. It adds the amount to the recipient. Then it emits a transfer event so that the wallets and front ends can reflect the change. Now, what is the benefit of moving this function or this logic into an internal function? So we get a very clean and reusable code here, fewer bugs because from duplicated logic. Now again, if you're writing more lines of code, there's a high chance that there would be more errors, and a single source of truth for how balances are updated. Now, even if we write two different transfer functions, one is for a direct transfer and one we're saying transfer from, it can just rely on underscore transfer to keep things consistent and not repeat yourself, right? So now we'll just quickly see how we can write a transfer function, a simple one. Function transfer. Okay. And then we're saying, hey, address 2, because oh god, this is me directly transferring, or whosoever the message sender is, and then uint 256 value, and we are making it public returns, and now we want them to actually return a bool success, because again emit is already happening. Internally, a call could happen and then just let us know that success is like it is successfully done. So we just check that balance of message.sender. If it is greater than equals to value, underscore value, great, you're rich, come on. Otherwise we say, hey, not enough balance, right? Oh, not like this. Yeah. Okay. Oh, come on. What is this? Yeah. And then we say, okay, let's just call the transfer function. So I say if I call the underscore transfer function, then message.sender is the from address, right? And then underscore to whosoever we are sending it to, value is same. And then we're saying, hey, can you just return true if it works perfectly fine? So what is it that we're doing? We've done a logic split. Okay, first we're ensuring that message.sender has enough tokens using the require statement. Then instead of handling the transfer logic here, we're calling an internal function called underscore transfer that performs the actual token movement. Now I've already explained that why did we split it. That brings us to a very important design pattern, which is again separation of logic. We've already talked about. We do not want to duplicate the transfer logic across multiple places, because we've already figured out that there could be two scenarios: me distributing the funds, someone distributing the funds on my behalf up to a certain allowance and all of that. So you can just think that this transfer function is going to act as a front end button, and then the underscore transfer, which is an internal function, as the backend engine. So the user will only see the transfer button, but the real action is happening from underscore transfer behind the scenes, right? And then another very important benefit of this approach is the safety and the consistency. If we ever want to change the way token balances are updated, like adding a fee or logging an extra data, we only need to modify underscore transfer in one place, and then both transfer and transfer from, which we are going to write next, will benefit from the update, right? So, okay, now that we've talked about transfer from so much, let's just get to write it. Have I missed something? Yeah, I have missed a curly face, closing curly face. What is the problem here again? Sorry. Oh, we're actually, okay, we don't need it from here. We can just say message.sender. I don't need it here, right? This is wrong. Yeah. Balance of message.sender greater than equals to value. Yeah, now this is right. I had a extra square bracket at the wrong place. Yeah. Okay. Now let's write the transfer from function. Okay. Function transfer from. Okay. Now, address from, same, address to uint 256 underscore. Okay. Again, we'll be using the internal function. So we'll say, hey, can you just return success? Yeah. Okay. Now, what is it? So we'll say, hey, I need to check if the balance of whosoever is the from address, right, has enough, right? So I say greater than equals to underscore value, and I say not enough balance. Okay. And then I also say, okay, because we're talking about allowance here, we really need to check another condition which says, hey, can we check for an allowance? Yeah, we have done the mapping here, right? So we say underscore from and then message.sender greater than equals to value, no allowance, not enough allowance is fine. Okay, let's just chuck this and just put a semicolon. Yeah. And then we say, okay, how are we deducting this? So we're saying, okay, now that we have checked everything, we'll say allowance from message.sender, whatever that money was, right? I will deduct the underscore value because come on, if I have allowed only 20% of it, it's not like every time you can spend 20%. If you've spent, if I say, okay, I have 100 tokens, you can spend 20 without asking to me, and you spend 10. So then for this month, or as part of your allowance, you can only spend 10 more without me asking, right? Otherwise, you will just keep repeating it. So we just subtract it from the allowance, and then we again call the transfer function. And we say, okay, from underscore to underscore value, very smart. And then we say, oh, yeah, thanks. And then we say return true. Okay. So this works completely fine. I hope everything's clear. Given you an example that someone who's been approved to actually move token on someone's behalf. For example, Setu calls approve Sneha, 100, and then Sneha calls transfer from Setu to, I don't know, Yash, 50, right? So then Sneha is the message.sender, and then Setu is underscore from, and then Yash is underscore to. So yeah, that is how it works. Like, come on, you've understood what the basic logic here happens, right? So this function does three things. It checks if the person actually has the tokens, right? Like whosoever is the from. It checks that Sneha has be like approved, or yeah, this person has been approved to send at least that amount, and then it decreases the allowance by that amount, and then it calls the underscore transfer function to perform the actual token movement. And then this function is what actually makes things like DEX swaps and DAO voting possible. Anytime a smart contract moves your tokens, it's probably using transfer from under the hood, right? Now, we would also need to have an approve function written, okay? Now, again, this is more like a transfer thing where you're allowing, but then if you want to give another address, usually a smart contract, the permission to spend token on your behalf. For example, in a real world analogy, you give a friend a signed permission slip to take $50 from your wallet. They can't take more than that, and they need the slip to do it, right? So you will need written approval. So similarly, yes, function approve, and we say, okay, address of the spender, and then uint 256 underscore value, and we say, okay, public returns again bool, fine. And then we say, hey, let's check allowance of message.sender with the spender, right? Okay, smallest spender is equals to underscore value. Here it's different, right? We're saying it has to be equal to the value. Okay. And then we say, okay, emit. Now we have written something as approval, right? So we're saying, hey, approval message.sender underscore spender and then underscore value and then just return true, right? Because yeah, this has been successful or this has been approved. So it's like a sign, a success sign, right? So spender is the address that we are authorizing. Underscore value is the maximum amount that they are allowed to spend. And the allowance is stored in a nested mapping, allowance, owner, spender. That's how we wrote it. And just like we transferred, we emit an event approval to let outside world know that, hey, this has happened. Right? So this is the foundation of all delegated token movements like trading and etc., subscribing to a service, or participating in yield farming and all of that. And this function basically only sets permission. The actual transfer is done via transferFrom. Okay, so this is just a function setting permission. No real thing is happening. No logic is implemented. It's just approving and then emitting an event, right? Now, what is missing in this code, right? Let me zoom out. Yeah. What is missing, right? We've built an ERC20 contract and that's awesome, right? But before you rush off to launch it on mainnet and start your own blockchain empire, there are a few things that this minimal contract doesn't do. And they're very important and you need to know it before we look into the deployment and see how things are working, right? No protection against approved front running. So this is a very well-known issue in ERC20 where someone could exploit a race condition to spend more than they are supposed to. So the fix could be use increase allowance and decrease allowance instead or other safe patterns. No minting or burning. The supply is fixed at deployment. You can't increase it or reduce it without adding extra functions. We're not talking about any access control or ownership, no pausing or circuit breakers, there's no upgradability, modularity. Once it's deployed, it's logged in, you can't upgrade the logic unless you redeploy, which could be very messy if your token is already in circulation. And that is why we've said that this is only relevant, like this discussion is only relevant when you're talking about launching or thinking about launching it on the mainnet. So this contract is perfect for learning, right? And we'll quickly also look into the Open Zeppelin end, but let me compile this very quickly and then deploy it. Okay, so it says initial supply. Now I want to keep it very small. Okay, I'll say 5,000 tokens. Okay, now you'll see what happens. It will be 5,000 into 10 to the power 18 when once I check the balance, and it will say, hey, come on, name, Web3 Compass, symbol, WBT, total supply, whoosh, long number. You can count the number of zeros that it has, right? Now, because I am the message.sender, I say, okay, balance of, and then I check it, right? Right now it's allowed. Okay. Now I will say, okay, can we do this that I copy this address allowance, right? Which is, when we write it here, okay, this one from an address to address and then, mapping. I say, okay, I want this person to be allowed. It said, okay, right now if you check, it's 0, right? We're not doing anything. The value is set to 0. And I'll say, okay, I want to approve a spender where I say, hey, this is the, have I put the right address? Yeah. And I want to say, I want this person to spend 200. Okay, it goes through. Now, can you check the allowance here? 200, right? That is how it happens. Now, I've allowed this particular address. Now, there are two things. Okay, one is transfer. So, you will see that it just says, hey, you know what? You have to transfer to this and then the value should be this address. So, I will say, okay, let's just send 200. No, 250. Okay, I go transact. And then if I want to check the balance of that particular one, I say, hey, 250, right? And then transfer from, which is a different function, right? So I'm saying, hey, you know what? First, let me check my own balance now. Okay. So, wow. So, it was something 500, blah, 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 and you spent 250. So in the end, you can see 750, even if you cannot do the entire calculation, and it's totally fine, right? But then now this particular person wants to, do it. So I will just change this and I'll say, okay, you want to spend, which address is this again? My God, I've just gotten confused about the entire address thing. I should save it. Yeah. And then I want to send it to, I don't know who, maybe this person. Okay. And I'll go here because assume that this is Seto's address. Okay. And this person has the allowance of 200 tokens and I'll say, hey, 100. It goes through. Great. Right. Now, if I want to just check the balance of this person, let's just check the balance here. It changes 650, right? So then we did the transaction through this account because this is the account that had the allowance to spend 200 tokens. And I've spent 100 already and you saw the deduction. Now imagine if this particular account says, hey, now you know how much is the allowance, right? Let's check this. 100 is left. Now let me say I want to transfer 150 and transact it. And it says, hey, not enough allowance. Why? Because it's only 100 left. So that is how it is happening. And you see that even if transfer and transfer from did not have any logic implemented, it was just calling an internal function, everything happened. Like, how cool is that, right? So yeah, I think this is all that we have to talk in this account. Now I will quickly show you an ERC20.sol, which we can write using OpenZeppelin. A very small, little, cute contract it is. Where did my token go? My tokens. Let me just copy this. Come here, right? Now, everything remains same, okay? Now, that is just like how we had an ownable.sol. We have something called as a ERC20 from OpenZeppelin, and this is how you write it. @OpenZeppelin, again, it's library contracts token. Oops, sorry, I messed with it. ERC20, ERC20.sol. Okay, and now you will quickly just go, hey, contract, my token, and then you say, hey, we are using inheritance. I know what this is statements do, right? And it says, hey, ERC20. Why is it showing no arguments passed? Yeah, it's okay, right? And then initially this has a certain standard that you will have to have initial supply, just like we did in the, previous one, that with constructor we gave an initial supply. So I say UN256 initial supply. Now using ERC20 standard from OpenZeppelin, there is this thing where you have to just give your name and symbol. Okay, so just like it says my token MTK, I will just go through Web3 Campus. And then I will go about the symbol, which is, come on, W3C. Suppose. Like, I know it's not very good, but yeah. And then it will use an internal function called mint. Okay. You'll read about this, and then this entire mint has to give these two things, a message.sender and an initial supply. Here, initial supply has to be multiplied into 10 into whatever decimals, and here, the decimals are actually by default taken in as like whatever you're providing, but generally it's 18 is what we provide. Okay. Cannot be applied to types. Okay. Sorry. Yeah. Okay. And that's it. Like, that's the entire thing, okay? That's it. You've just created a production grade ERC20 token in a few lines. Let me just compile it quickly and show you. Okay, I'll just close this entire thing and I will deploy this and I will say, hey, let's do 4,000 and deploy it, okay? And oh, yeah, no. Yeah, this is the new one, right? So it has decimals, name, Web3 compass symbol, W3C, total supply 4,000, blah, blah, blah. And it has allowance, balance of, transfer from, transfer, approve, and all of it, right? But you can also go further, explore OpenZeppelin more, gives you plug and play extension like ERC20 burnable, pausable, access control or ownable, ERC20 permit for gasless approvals, and all of it. You can pick what you need, compose it into your contract, and you're good to go with all the security and best practices to be kicked in. And once you actually start working, writing more contracts, I think this is what you're going to use more instead of writing things from scratch. But yeah, I think that's all for day 12. Now, as a quick recap, we learned why ERC20 exists and how it standardized token behavior across Ethereum. What name, symbol, decimals, initial supply, total supply do mean, how balances and allowances are used, how to approve and transfer tokens, and how OpenZeppelin can do all of this in just like 5-6 lines of code, right? And yeah, let's keep going. Let's keep building. I will see you for day 13. Bye, guys.